Hello friends, today I'll discuss about collapse load. I'll not go in deep, but today I'll discuss how to find out the collapse load in case of several types of supporting condition and several types of load condition. Okay. So generally today I'll discuss about a simply supported cases. How to find out the collapse load in case of a simply supported beam. Suppose it's a simply supported beam having a point load Pu acting at the middle of this beam, that is L by 2 and it is L by 2. Okay, so I'll discuss how to find out the collapse load in this case. If this beam will collapse, so it will be in this way, or shape will be in this way. In this way beam will collapse, so it will produce angle theta here and it will also produce angle theta here. So this is the elastic hinge, this is elastic hinge, and this is the point of plastic hinge. Okay, plastic hinge, it is a point of plastic hinge. Okay, so if this angle is theta, this angle will also be theta and this angle will also be theta. So friends, now I will discuss how to find out the collapse load. So suppose the moment carrying capacity of this beam is mu. So for condition for finding out the collapse load will be external work done. Work done equals to internal work done. Internal work done. Okay, so now I have to find out what is external work done and what is internal work done, and if we equate these two, then I will easily find out the collapse load for this beam. So now here, see here it is L by 2, this is also L by 2. So and suppose this beam will deflect here by amount of delta. Okay, by amount of delta. So what will be the value of the delta? We know that theta equals to theta will be delta by L by 2. Okay, from here it is a deflection delta, so from here you can write or delta equals to theta into L by 2. Now we know that internal work done equals to mp into theta here. For this, as plastic hinge is forming here, so for this portion it will be mp into theta, and also plastic hinge will form in this here, so that's why here also be internal work done will also be happen here, that's why it will be mp into theta. So that's why mp into theta plus mp into theta, so it will be mp into theta plus mp into theta, 2 mp into theta. Okay, now we have to find out the external work done. So actually external work done is nothing but it is the force into displacement. Here force applied force is pu and displacement is what? Displacement is delta. So I can write here force, so external work done equals to pu into displacement delta. So what is the value of that? Is a pu is given here and value of the delta is nothing but theta into L by 2. So I have to put the value of delta here, theta into L by 2. So this is the external, so this is the number 1 equation and it is the number 2 equation. So what I have to do, I have to equate these two equation. So from this I will get the value of pu for the applied moment mp. Okay, so 2 mp 2 mp theta equals to pu into theta l by 2. Here theta and this theta, this theta and this theta cancel out, so value will be pu equals to 4 mp by l. This is the equation for collapse load for a simply supported beam having a point load acting at the middle of this beam. So in my next lecture I will show if this load acts at this point. Suppose it is in this case this load is acting at the middle point. Okay, if it was involved in case of, it is subjected in case of a eccentric load, that means suppose a load is acting here, the pu, and this distance is a and this distance is b. Okay, this distance is b, this distance a. So for this type of beam, what will be the value of the collapse load? In my next lecture I will show how to find out the value of the collapse load for this type of beam or this type of loading condition. Okay, thank you friends.